Hello and welcome back to my channel. So we did some of these problems in class, and so now we're just kind of finishing up some of the ones we didn't quite get to. The first one being example number 2 on this page. Find the area of the region bounded by the graphs of x equals negative y and x equals y times 2 minus y. So we're going to take these and find the area between these two pieces of this graph. The area that we're going to be dealing with is going to be this area here. So one of the things that we can do is, even though we don't know what our bounds are yet, we can use our graph to kind of help us out. But if our graph doesn't have whole numbers, or we're not sure exactly that it crosses at whole numbers, we may not want to use the graph entirely. But if we're crunched for time, it's not a bad idea. So we have our area is equal to the integral of the bounds we're going to find in a second of our rightmost function minus our leftmost function. So our rightmost function is the function that when we look at it, it has values that are always to the right or more positive. So when I look here, if I were to create a line between these two, the functions that are the numbers that are on that parabola are to the right of the numbers that are on that line. So I know that our parabola here is our right function. We are going to subtract our left function, and that happens to be the other one. So we have the integral from the bounds that we're going to find of y times 2 minus y, subtracting it from negative x dy. So what we need to do is find the bounds. So in order to find our bounds, we want to know where these two functions cross, where they're equal to each other both for x and y. In order to do that, we're going to take our two equations and set them equal to each other. So I have negative y equals y times 2 minus y. We're going to multiply out y times 2 minus y to get 2y minus y squared. And then we're going to move everything over to the other side. Y squared minus 3y equals 0. We have a y in common for both of these, so we're going to factor out a y from both. So we have y times y minus 3 equals 0. And then because of the zero product property, we can set both of these equal to 0. So y is equal to 0. Y minus 3 is equal to 0. And then we're going to move stuff over. So we have y minus 3. So y is equal to 3. Y is equal to 0. So we have our bounds now. So we have 0 to 3. Depending on what type of question that we have here, we would then simplify what we have here. I would probably do what we just did, is multiply out y times 2 minus y to get 2y minus y squared. Minus a negative turns into a plus y dy from 0 to 3. To then get 0 to 3 of negative y squared plus 3y dy. From there, we could take the antiderivative and do all of those things, but I was also focusing on being able to use technology, so being able to use calculators to find out. Because we don't have necessarily the technology that we would need to do that at home all the time, let's do the math behind it. So we would integrate both sides. So we have negative y cubed over 3 plus 3y squared over 2, evaluated from 0 to 3. Then we're going to use that fundamental theorem of calculus number 1 to evaluate these interval bounds. So we have our function with 3 plugged in. And we are going to subtract that from our function with 0 plugged in. If we look at the right side of this, all those zeros are going to go to 0, so we have 0 plus 0 is 0, and then we're taking 0 away, so all of that goes away. We have negative 3 cubed over 3. Well, 3 cubed divided by 3 is going to be 3 squared. 3 squared is 9, so I know that this is going to be 9. Plus 3 cubed times, or 3 squared, what was I doing? 3 squared times 3 is actually 3 cubed. 3 times 3 times 3 is 27, so we have 27 divided by 2. We're going to change negative 9 to in terms of 2, so we have negative 18 over 2 plus 27 over 2. If I do 27 minus 18, this gives me 9 over 2. So I know that my answer is going to be 4.5 or 9 over 2.